Okay, we've got a minimization problem here. This is the one out of the text. Actually, it's problem number 84, the one we did in class. In the, I think it's the 11th edition. It's on page 332. Actually, kind of a nice diet problem. Battery park stable feeds. And right at the bottom of that page for problem 84 are all the constraints. Again, this is a minimization rather than a maximization problem. And so normally what we would do is minimize for cost. That is certainly the case in this particular problem. But we'll go through all the different constraints and make use of those. In this one, we've got actually 6 constraints, it appears. And 3 products, or 3 variables, so it is multilinear. Also, we want to click on minimization because it's a minimization problem. Click OK, and we've basically got our important components right here. So for our products, again, we always want our products. Well, for whatever reason, I do not seem to have enough constraints. No harm, no foul, though. We'll just put in a couple extra. Okay, we always want to look at our products for up top here, and it's oats, grain, and also minerals. And there's USDA requirements. As far as the cost is concerned, it's 9 cents for the oats. It's 14 cents for the grain, and for the minerals it's 17 cents. Okay, let's go to the first constraint. Again, we're minimizing, so actually those constraints are A, let me just make this easy, B, C, D, and E, and we still need one more constraint. And the last constraint is that we have to have less than 6 pounds per feeding. Okay, so the USDA requires, or not requires, but recommends at least 6 units of, I guess, vitamin A, and there's 2 units in the oats, 3 units in the grain, and 1 unit, whoops, 1 unit of minerals for product B. We've got 0.5 units of product B in the oats. In the grain, I'm just grabbing a piece of paper so I can keep track of all these. Okay, so that's 0.5, 1, and 0.5 units of minerals, or in the minerals for B, and it's got to be greater than 2 units. For C, it's going to be 3, 5, and 6, 3, 5, and 6, and it's got to be greater than the USDA requirements of 9. Okay, for D, it's 1, 1.5, and 2, so 1, 1.5, and 2, and that's got to be greater than 8 units. And E is 0.5, 0.5, and 1.5. 0.5, 0.5, and 1.5. and then that has to be greater than 5. And lastly, we want to make sure that there's they have less than 6 pounds. So that's actually going to be less than. And we code that for the algebraic equations as we had discussed in class 111. And just let me double check our numbers here. Okay, we're minimizing for cost. Our 3 products, oats, grain, and minerals. For instance, product A has 2 units of mineral or A in oats, 3 in grain, and 1 in minerals. Yeah, that looks pretty good to me. 3, 1, just double checking. Okay, just double checking. Looks real good. I think we have our completed linear program for this minimization problem. I'll just go and solve real quick, and we have our answer right here. You can see that with a cost of 9 cents for oats, 14 for grain, and 17 for minerals, we should give the horses 1.33 pounds of oats, 3.33 pounds of minerals, and none of grain at a total cost of 69 cents per feeding or per day. Seems to actually works real well, makes perfect sense. You know, I'd love to be able to provide the graph, but of course we're in 3 dimensions here with the additional constraint. So there is our minimization problem. I'm hoping this is of value.